Hello, everyone. Welcome to Mathematics with Shahab Yaku. Now, tomorrow you'll be having your P3 exam. That's paper 3. And yes, we are talking about this particular session. So it's a good idea to give you a brief overview. Well, it won't be that brief. So I think it would be at least 1.5 hour worth of time to explain to you in great detail what, in my view, so this is strictly my viewpoint, that the paper would look like. Now, there will be a lot of variety of questions, so I'll try to cover them as much as possible. So now we are starting with the first subtopic, that is focusing on algebra, logs, and trigonometry. So let's look at algebra and logs first. And now the questions will be coming in different order. So I did not have that much time to arrange everything. So let's go very, very randomly. This first question is about modulus inequality. There is modulus on both sides. So now the rule is when there is modulus on both sides, only then square both sides. When it's modulus on one side with a lesser sign, we will write this thing as x lies between negative a and positive a. When it's a modulus on the left, and from the left perspective, we write it x modulus greater than a, that is x is greater than a, x is less than minus a. I'm not very much inclined towards using graph for modulus inequality because not everyone is very comfortable with graphs, but most people are comfortable with algebra. So that's how I work. Square both sides. Remember, this 2 will also get squared. And then you are back to the basics of P1. P1, quadratics, that's the heart and soul of pure maths. You expand, you simplify, you get this thing. And now the equation is in terms of a constant A. That is what is different about it. So expect something like this. It's just an educated guess and nothing more. Middle term factorization, simplify, draw a sketch. Drawing a sketch is a must for solving a quadratic inequality because it's not a linear inequality. So greater, that means the region above the x-axis. Extreme right, you will go up. Extreme left, you will go up. You will write the answer as it is. Similarly, in this particular question, they're asking us to draw this graph. So, well, we will go ahead and draw this graph, but nobody is forcing us to solve the inequality using the graph. That is what I'm emphasizing on. So we draw a straight line, positive y-intercept, positive gradient, negative y-intercept. This is where the graph cuts the x-axis. From here, the graph will assume a V-shape. The negative values becomes positive, 0 remains as 0, positive remains as positive. Then it says solve the inequality. I'll keep the modulus on the left-hand side. This is case number 1. Open it up like this. Solve this separately, solve this separately. When we solve these two, what happens? They are moving in the same direction. They are pointing towards the same direction. Now, is it like the intersection of the two sets? Is it like the union of the two sets? What it is? So now the rule is, that's called the true and false test. Choose a number between 1 and 1.5 and plug in the original inequality. Choose a number from 3.23 over 2 onwards, 1.5 onwards, and then plug in the original inequality. When I plug in 1.25, what happens? It does not satisfy this inequality. That means this is a representative of this region. So this region is not right for us. This is proving the inequality, it's true. That means this is the correct region. So therefore, x is greater than 3 over 2 is the answer. Now, some people, they ask this question, what if this was true, this was true? Naturally, this whole thing is the answer. What if this was false and this was true? That means the region below 1 and 1.5 will be the answer. So that's how we do it. A question involving logs and linear law. Ln y is on the y-axis, ln x is on the x-axis. It's passing through 2 points. That's what it's written over here, and we have to solve this equation. So the first thing, that's about coordinate geometry. The gradient, y is equals to mx plus c. I've written the y in a weird manner and x in a weird manner because x is not x, y is not y. And then I plug in any one of the 2 points. I evaluate c. So we won't do it graphically because it's not a scale diagram. It's not an exact graph thing, plotting thing. The next thing is break this equation take ln of both sides, because there is ln over here. That is why we take ln of both sides. If it were to be lg, we would have taken lg of both sides. So according to rules of log, simplify and make ln y the subject. Why? Because we are plotting ln y against x. So let me just correct this thing. So we are plotting ln y against ln x. So ln y is negative n over 2 ln x plus half ln c. That means this whole thing is the y-intercept. This coefficient over here of ln x, that is the gradient, that brings us to the third step. We have calculated the gradient, equate it to negative n over 2. So n is 0.8. And half ln c equals to this y-intercept, make c the subject, you get the answer. They are saying find the value of n, find the value of c, correct to 2 decimal places. So that's how we get this thing. If it's 2 decimal places, then we should write 0.80. A question related to polynomials. The polynomial, the cubic polynomial is given. The simple question, it is given that x plus 2 is a factor. If x plus 2 is a factor, that means if I plug in negative 2, the remainder is 0. This is an application of factor theorem. The next information is when it's divided by x plus 1, the remainder is 2. That means if I plug in negative 1, it should equal to 2. Form 2 simultaneous equations, solve, and you get the answers. Pretty basic stuff. Now this one, the polynomial where a and b are constants is denoted by px, where px is, when px is divided by this thing, the remainder is 3x plus 2. Now in this one, I'm giving you an example from basic arithmetic, basic numbers. 7 divided by 3, 7 is inside, the divisor 3 is outside, 3 2s are 6, remainder is 1. This 2 is called the quotient, remainder is 1, divisor is 3. So this can be written as 2 plus 1/3, quotient plus remainder over divisor. Now, if I want to get back the 7, I'll multiply 3 into 2 plus 1. So quotient into divisor plus the remainder. Quotient into divisor plus the remainder, that is that particular number. So that number, that polynomial is basically quotient. This is actually divisor. And the quotient, let me write this thing as ax squared plus bx plus c, or 2x squared plus qx plus r. Let me explain to you why have I written 2 over here. Plus the remainder 3x plus 2. I have written over here because I can observe that this x squared multiplying with this x squared should give me 2. So if this coefficient is 1, naturally this comes out to be 2. And the rest is basically just multiply, simplify, comparing coefficient, and then you get the answer. So all these questions that I'm explaining, some people might find it a little bit faster, so slow it down. YouTube is there. The option is there. Some people might find it slower. They can speed it up. And of course, you should pause. You should look at it. And the source from which I've taken this paper, that's right over here, the years and everything. Now, another question related to ln. Solve this equation. Rule of log, this 3 becomes this power. This minus means division like this. ln of something, that means something equals to something. Solve, you're getting the answer in the exact form. They are saying give answer correct to 3 significant figures. Yes, if they would have asked for the exact form, we would leave it as it is. Otherwise, work in 4SF, final answer 3SF. Something like this. Find the real root of this equation, giving your answer correct to 3dp. Your working should show clearly that the equation has only one real root. So this is 2e power x. I have written e raised to power of negative x as 1 over e raised to power of x. The same as over here. Actually, it's just 2 plus ex is equals to 3. Make a substitution in the beginning so that life becomes easier. 2u plus 1 over u divided by 2 plus u is equals to 3. Simplify. Division becomes multiplication, 1 over this thing. And then we get a quadratic equation. Life is not always perfect. So it's not necessary that it will always factorize. So quadratic formula is there. So root 1 is this thing. Root 2 is this thing. This is root 10 minus 3, which is a positive value. This is negative, which is negative. You cannot take ln of a negative number. No solution, only one solution. So that was a nice question. Another question related to, again, linear law kind of thing. 2 variables x and y satisfy this equation. Explain why the graph of y against ln x is a straight line and state the exact value of the gradient. So basically, you have to break it up. ln x, ln of these two, that is ln of the first and ln of the second. Take this power down, simplify, and it's saying a graph of ln x. So ln x is on the left. So on the left should be our y. And something attached to a constant, that should be the other variable. And this constant, that should be like mx. So this is negative ln x. And actually, I have done this thing. It says y against ln x. So it's not ln x against this thing, it's y against ln x. So that's why I'm taking this to the other side. And then I simplify it. So ln x is on the right hand side, y is on the left hand side. This constant over here is the gradient. This c is like this. So sometimes it could also be a possibility, the graph of x against ln y. So now, no, it's in this particular question, it's y against ln x. This is gradient, this is y-intercept. Calculate the value of a, giving your answer correct to 2 decimal places. It says it is given that the line intersects y-axis at the point where y is 1.3. So when y is 1.3, it's intersecting the y-axis. Therefore, x coordinate is 0, but x is not x. What is x? X is ln x. So therefore, you would simplify. You would use this equation. Instead of ln x plus plug in 0, y is 1.3. Simplify, you find a, and that is, they're only asking us the value of a. Partial fraction, something very important, coming with binomial, coming with integration. Over here, the very first thing that should be checked whether it's proper or improper fraction. In this case, it's a proper fraction. So the highest power of the numerator is 2. The highest power of the denominator after multiplication is 3. So it's proper. Then decide on the case. This is a linear factor. This is a quadratic factor. Write bx plus c and make sure to put it in a bracket, because otherwise when you will be taking LCM, you'll be making some mistakes. So now take LCM. The denominator equals to denominator. The numerator equals to numerator. Substitution is the way. Find a, b, and c and make sure to write the answer in a fraction form, because they're not asking us for the constants. Those constants were introduced by us. They are asking for fx in partial fraction. So this is a must. And then this thing that's quite boring. It's time consuming. But in order to gain marks, 5 marks, that is, you have to work it out. Hence, obtain the expansion of fx in ascending powers of x up to and including the term in x squared. So basically, take this up, take this up. When we take this up, this 4 is still there. Make sure the first term is 1, because this is 1 plus b raised to power of n, and that's how you expand it. This minus 1 applies to 2 also, indices. So 4 into half into this bracket, this becomes 2. Simplify, multiply. These are the 3 terms that we get. Over here, 1 minus 2x was at the top. 3 plus x square raised to power of negative 1. 3 common. 1 plus x square over 2. The whole thing raised to power of negative 1. 3 raised to power of negative 1 is 1/3. This is 1 plus x square over 3. Again, the expansion. Again, the simplification. Then selective multiplication. As such, you have 2 terms, you have 3 terms. You'll be ending up with 6 terms, but you don't need all that. Why? Because you're just working till x squared. So use this one, multiply with the first 2. Use this x, just multiply with this one. So as such, this thing was not asked for. I just wrote it extra. You can dump it any time during the course of the question. So at the end, you can dump it. These are the 3 answers that I got. Now, this partial fraction, this is improper, because the highest power of numerator, highest power of denominator is the same. What's the first step? That is the dividend, the divisor actually. Multiply it out. Second, algebraic division. You should be very well versed in algebraic long division. Highest powers are the same, only one step. 4x squared over 2x squared, that's 2. Multiply with each one of them. Write it down, change the sign and add. That's another way of subtraction. This is quotient, this is remainder, this is divisor, and this is already the factorized form of the divisor. Now you would work out the partial fractions with this one. So just the basic thing, partial fractions, and then don't forget to add that quotient back. Now trigonometry, trig identities. We deal with sine square plus cos square equals to 1. And similarly with cosec square and cot square and sec square and tan square and the addition formula and the double angle formula, everything is there. It's given in the formula booklet. So let me open up the formula booklet for you. I think it should be somewhere over here. Yeah, there it is. So the formula booklet, that's right over here. And First of all, it starts with this mensuration formula that is as such not needed. Yes, let me just tilt the page like this so that it's easier. I think there's a lock over here. And let me just cut it out. So the screen capture, the arithmetic series, binomial, all these things are there. And over here, this is what I'm interested in. You're not interested in the principal values. So I've copied it. And then the differentiation and the integration and all these things, by parts, everything is there, the scalar product. So going back to that, so let me add a page, or let me just paste it over here. And that is what we are using. Okay. So now it says prove the identity cot minus tan. Cot plus tan is cot 2x. Cot can be written as cos over sine. Tan can be written as sine over cos. Take LCM. And we know that sine theta cos theta. So first of all, I'm dividing. Cos square minus sine square over sine cos. That is the numerator. And the denominator is over here. So cos square plus sine square is 1. When we divide the numerator and denominator, the sine cos cancels out. And this is exactly cos 2 theta. So that is cos 2x. I wrote theta. That's the same thing as x. Another question, that is the compound angle form, the harmonic form. Root 7 sine x plus 2 cosine x, that's written in the form r sine x plus alpha. Make sure if it's a sine, the first term, then it should be a sine over here. Why? Because then this is a and this is b, and tangent of alpha is b over a. So the order makes a difference. R is positive, alpha is acute. So this is a, this is b. R Pythagoras theorem, alpha basic angle, work in 2 dp, final answer 1 dp. So now the next part, it says hence solve this equation for theta between 0 and 180. So it's back to the basics of P1. So make this bracket the subject. This is 1 over 11. It's positive. So first and second quadrant, 2 theta lies between 0 and 360 because theta lies between 0 and 180. And then we are adding 37.09. So this is added, this is added. Let alpha be the basic angle. Since we have used the symbol alpha before, you can say let's use beta. So this angle comes out to be 17.55. First quadrant, 180 minus basic angle for the second quadrant. Now what happens is that this intermediate range, this first answer is out of the range. So it's cancelled. That means if this first answer is over here, 17.55 degrees, therefore I can take a whole revolution and I can reach back the same place. So I'm adding 360 degrees over here because the range is extended in this direction. So now both these values are within this range, make theta the subject. That's how we get the answer. The next question, using addition formula. So tangent a plus b is equals to 2 cot x plus 1. Tangent a plus b, tangent a plus tangent b, 1 minus tangent a tangent b. Cot can be written as 1 over tan. Okay, now, so let's get started. Tangent x plus 45, this is broken up. Tangent of 45 is 1. 2 cot x, that's 2 over tan x. So now it's again back to the basics of algebra. Cross multiply, simplify, middle term factorization if possible. If not possible, quadratic formula. So you're getting two values of m. M is negative 1 plus root 5 over 2. M is negative 1, negative root 5 over 2. But what is m? M is tangent of x. So tangent of x is this value, first quadrant, second quadrant. Tangent of x is negative of this value. That's the second and the fourth quadrant. We calculate the basic angle with the positive ratios and then take care of it. These are the final answers over here. Another question related to addition formula, cosine 3x, sine x, sine 3x, cosine x. We cannot just expand without thinking. Now thinking is a must. First think. So cross multiply, cross multiply. This is cosine 3x, cosine x, sine 3x, sine x. Isn't this like the expansion of this? So cosine a, cosine b plus sine a, sine b, that is cosine a minus b. So a is 3x and b is x. So this is cosine 2x. What's in the denominator? Sine x, cosine x. That is sine x, cosine x is sine 2x over 2. So divide, cos over sine is cot. Division by half is multiplication by 2. The next one, hence solve this equation. So basically 2 cot 2x is equals to 4. Cot 2x is equals to 2. Therefore, tangent 2x equals to half. And then it's back to the basics. I think it's the same question. No, it looks very similar. I think it's the same. Tangent, where it is, this one. As a quadratic equation and solve for this. I think I might have pasted it twice. So that happens. Yeah, something like that. Now, this one is a good one. Slightly different, one of my favorites. The angle alpha and beta lie between 0 and 180 degrees is such that tangent alpha plus beta is 2, tangent alpha is 3 alpha beta. 3 tangent beta. Find the possible values of alpha and beta. So they both are lying between 0 and 180. Step 1, expand this. Now substitute tangent alpha in terms of tan beta. So instead of tan alpha, write 3 tangent beta. So now everything is in terms of tan beta. And they are saying tangent alpha plus beta is 2. So just write a 2 over here. So cross multiply, and this is like too much of that. Working of quadratics and then factorization. Tangent beta is -1, tangent beta is 1/3. Tangent beta is -1, beta lies between 0 and 180, but tangent is positive in the first, negative in the second. Basic angle is 45 degrees, therefore 135 degrees. Tangent beta is 1/3. Yes, the range is between 0 and 180, but we are only interested in the first quadrant because tangent is positive in the first quadrant. Basic angle and this answer. And then what is it asking? Find the possible values of alpha and beta. So I think it's all good. Tangent alpha. Oh, this is beta. We also need alpha. So we have to work it out. Now, differentiation and integration, the major chunk, actually differentiation, integration, differential equation, and sometimes differentiation integration also appears in numerical solution. So that is a major chunk. Now, let me just double check my recording status. Everything is good. Everything is clear. So now, let's look at this question. I have written in the box, and you should make a habit too. Sine 2x is 2 sine x cosine x. Cosine 2x, there are 3 formats. Now it says the diagram shows the curve y is equals to sine x cosine square 2x x between 0 and pi by 4. This is 0, this is pi by 4. And the maximum point is m. Definitely, m should be a value between 0 and pi by 4. Now, in these questions, sometimes they make us do the differentiation first and then the integration. And sometimes it's the other way around, as in this question. It says use the substitution. U is cosine x. Find by integration the exact area of the shaded region bounded by the curve in the x-axis. Now, it might seem very trivial. Why are they writing find by integration? I mean, is there any other way? Maybe someone can just draw a basic graph kind of thing, a scale diagram, and choose small square, and someone has all the time in the world to do this. I mean, the examiner can expect any sort of permutation combination. So that is why they say by integration. So first of all, this is, let me write it down. So this is integration using substitution. That's also known as change of variable. So in change of variable, what do? We change everything from one variable to the other. So now when we get started, what do? We first start with differentiation. We are doing integration. We are starting with differentiation. U is cosine x. That's part of the method. It's not that something optional or something. It's part of the method. U is cosine, du is negative sine x. Okay. So first of all, and also let's get rid of this. The limits 0 and pi by 4, convert it to the limits for u. This is 1 and 1 over root 2. No need to rationalize as such. That we can decide it later on. Now sine x cosine 2x the whole thing square. I first wrote it like this. Then I wrote 2 cosine square x minus 1 whole square. Why? Because I need the derivative over here. And also, I have u as cosine x. So that is the reason why I'm writing it like this. So now this sine x dx is negative du. So this negative is there and this du is there. This is 2 cosine square x minus 1. U is cosine x. That's 2u square minus 1 whole square. Now, this is simple expansion. These are the limits, and then you work it out. The next part, find the x coordinate of m, give your answer correct to two decimal places. A product rule, u prime, v prime. A word of caution, that is, when we are differentiating, just differentiate, then simplify. Whether it's using double angle or some other angle. So first differentiate, then simplify. So I first differentiate, then I'm simplifying based upon the demand of the question. This multiplies with this multiplies with this. I have seen that there is a cosine x common, there is sine x multiplying with this, there is cosine x multiplying with this, and then what I have done is that I have opened up the bracket, and then I have taken common out. So over here, we have this thing. Actually, this is the first bracket. I haven't taken common out. First, I'm writing it. Then this blue box is the taking common out. Then simplify on the inside. Sine 2x, it's a good thing. There is no alternative. Cosine 2x, you have to think. Since I'm getting a sine with a sine, that's sine square. So therefore, I'm choosing, which I chose later, because I first took common and then I chose. That's your choice. You can choose 1 minus 2 sine square and then take common. And then simplify and you get this. Now, it's just, it's not anything of a hard and fast rule, but that is the observation. That the answer won't be coming from this, won't be coming from this, it would be coming from the inside. It's just an application. Cosine 2x is equals to 0. These are the answers, not acceptable. Cosine x is equals to 0, out of range. So therefore, the only acute basic angle answer is from here. Now, question like these, in which we have y is something, prove dy by dx. So this can be done by chain rule. This can be done by quotient rule. I think chain rule is better. Take it up, raised to a power of -1. -1 comes down, bracket remains as it is, power reduces by 1. Don't forget to multiply by derivative of bracket and then simplify. Now remember this rule, derivative of a if it equals to b, integral of b equals to a. So this is my favorite question because it hasn't appeared for a very, very long time. The second part, that is proving identity. I think that is straightforward. Now, there is nothing magical about the left-hand side. This time, we are starting from the right-hand side and going to the left. Why? Because the right-hand side is bigger. So sec square is written as 1 over cos square. This 2 remains. Sec 1 over cos, tan sine over cos. Simplify, simplify, simplify. And that is what you get. Now it says, hence, find the exact value. So I'm interested in this part. Hence, find the exact value of this thing. Now, this fraction over here, isn't this fraction the same as this? The answer is yes. So therefore, I wrote 2 sec square plus 2 sec theta tan theta minus 1 equals to minus 1, and this is what I'm integrating. Now, the integral of sec square is written in the formula booklet, but the integral of sec tan is not written. That means it's not part of the syllabus as such, unless they have given us this hint. Derivative of 1 over cosine is secant tan. Integral of secant tan is 1 over cosine. So you have to use it. So therefore, integral of secant tan is 1 over cos. 2 remains as it is. Integral of 1 is theta. And then we plug in the upper limit. We plug in the lower limit. We work with the exact values. And this is what we get.
Recording in progress.
So now let's move to this next question. This is about parametric equation. X is ln bracket 2 plus 3t. And t is not equal to minus 2/3. Usually the examiner writes it when we are dealing with such an expression, because the denominator should not equal to 0. At the same time, ln of negative number does not exist. Ln of 0 does not exist. So whatever is inside the bracket, that should be greater than 0. Now, show that the gradient of the curve is always positive. X, we differentiate. Y, we differentiate using quotient rule. We find dy by dx, which is dy by dt divided by dx by dt, application of chain rule. We simplify and we have this thing. Now, for all values in the denominator, t is greater than minus 2/3. The denominator will always be positive. Therefore, dy by dx will always be positive. Show that the gradient is always positive. So that is what we have written. The next one, find the equation of tangent to the curve at the point where it intersects the y-axis. That means x coordinate is 0. This is the x equation. Make this equals to 0. Simplify. T comes out to be negative 1/3. Plug t is equals to negative 1/3. We find the y coordinate. We find dy by dx, that's gradient of tangent. Y minus y1 is equals to mx minus x1. That is the equation. Implicit, the equation of a curve is such and such. So it is implicit with a spice of exponential. Differentiate both sides with respect to x. This is an application of product rule because two functions are multiplying. This also is an application of product rule. This is basic differentiation. This is y into derivative of e raised to power of 2x, which is this. This is e raised to power of 2x, derivative of y, which is y1 multiplied with dy by dx. Minus sign is over here. Again, y square, derivative of ex into derivative of y square, which is 2y dy by dx. Derivative of a constant is 0. Grab all the terms with dy by dx on one side, push the others to the other side of the equal sign, make dy by dx the subject, and simplify. Now it says find the exact fractions, surd, exponential, ln, pi. These are all exact. Find the exact coordinates of the point on the curve where the tangent is parallel to y-axis. That means gradient is undefined. Numerator over denominator is undefined. In other words, denominator equals to 0. So this is the denominator. We equate it to 0. We get y is equals to half ex. Plug in the equation of curve and simplify. You get a beautiful answer. 1/3 ln 8 is ln 8 raised to power of 1/3, which is cube root of 8, which is ln 2. And we plug this value over here. And very, very important rule, not tested since a long time. That is e raised to power of ln x equals to x, provided x is greater than 0, because ln only exists for a positive value. Another question of partial fraction. I won't focus on partial fraction. I'll focus on the integration part. 3 over 2x plus 1, 1 over x squared plus 9. So now this is application of this rule. This one is application of this rule. If the numerator is derivative of denominator, yes, a 2 was missing. So this is 1 over a. The value of a is 2, ln 2x plus 1. Push this constant on the outside. Over here, 2 was missing. I wrote a 2, balanced it with a half. So this whole thing is ln of fx. The rest is plugging in the values, simplifying. Ln of 1 is 0, ln of e is 1. And then just look at this particular step. This is ln 9. So 3 over 2 minus half, this is 1 ln 9. This is half ln 25. Make this the power. That is ln 9 plus ln 5. That is ln of 45. Something to do with quotient rule. U over v, that is v u prime minus u v prime over v square. Ln x over x4, u is ln x, u prime is 1 over x, v is x power 4, v prime is 4x cube. Follow the rules. And I think I missed out one thing. That is division by v square, which is x power 4 raised to power of 2. So this is x power 8. Yes, when we equate it to 0, that denominator disappears. So x cube is equals to 0, reject. Why are we rejecting? Because we can see that m is not the origin. 1 minus 4 ln x is equals to 0. Therefore, x is e raised to power of 1/4. We find the corresponding value of y, and that is the answer for this thing. Integration by parts. That is u dv. That is the integral is uv minus integral v du. That's the way of writing it. This is the order for choosing u: log, algebra, trig, exponential. So this is about log and algebra. So Naturally, it has to be written as a product of two things. So x minus 4 is x power 4 is taken up, it becomes x raised to power of minus 4. U is ln x, derivative is 1 over x. dv is x raised to power of negative 4, v is this much. Whatever we take as u, we differentiate. Whatever we take as dv, we integrate. Then follow the arrows, because the arrow says what? U, v minus integral v du. U, v minus integral v du. And that is what we are getting. This is basic integration. Now, in these questions, things are not difficult. It's basically about your stamina. It's basically about how careful are you with the plus, minus sign, the exact forms, and so on. Take common when needed. I have taken common. Now, these limits, keep in mind, the limits are actually over here. So this is 1 and a. And then, yes, if you want to, you can get rid of this negative sign and switch the places. So that is what has happened. Let me again write the bracket like this. So over like this. Then we plug in the limit, because if the bracket is not placed properly, it gives a feeling that the limits won't be plugged in over here. Naturally, the limits has to be plugged in wherever the variable is. And then you simplify and you get this answer. It says show that this thing is lesser than 1 over 9. Now, this question had a strange ending. This is 1 over 9 minus all this thing. Now it says that if a is greater than 1, if a is greater than 1, this is positive. ln of 1 plus this thing is positive. Therefore, this whole thing is positive. Therefore, 1 over 9 is definitely there, but there will be whatever some positive value. Therefore, the answer would be 1 over 9 minus this positive value. Therefore, the answer is lesser than 1 over 9. Now, this was, I think, 2021. This was one of the toughest questions with this ending. Otherwise, it was a very normal paper. Something to do with tan inverse of half x. Y is equals to, let me put this thing in a box. So therefore, remember this thing. Y is equals to tan inverse of qx, dy by dx. This qx goes down, squares, add 1 to it. It's 1 over this thing into derivative of bracket. Tan inverse half x. So therefore, the derivative is 1 over 1 plus half x, the whole thing squared. Derivative of half x is half. And it's an again application of integration by parts, because 1 is over here. So dv is 1, u is tan, and 1 is integrated. And then follow this rule over here. So what do we have? We have this thing which is x over 1 plus 1/4 x squared. So now this is the application of this, which simplifies to this. So therefore, this becomes ln. And one other thing, someone can ask this question, that log, algebra, trig, and exponential. So there is this algebra, 1 will be counted as algebra, and this is trig. So why haven't we taken u as 1 and dv is tan inverse? The reason being, we know the derivative of tan, not the other way around. So it actually falls into this category. Why are we taking u as ln? Because we know the derivative of ln, not the integral of ln, which of course we do with integration by parts, but the standard is not there. So let me tell you what the standard is. That standard is written right over here. So let me just cut paste this thing. This is for integration, and over here it's for differentiation. So let me just capture this. And over here, if I focus on this, so save image, and actually I can just copy this. And let me add a page over here. Now let me increase in size. Now these are the derivatives that we are talking about. Fx, f inverse x. This is basic. ln, the derivative is 1 over x. And this is without the coefficient of x being 2 or 3 or something like that. In differentiation, the rule is that of multiplication. So coefficient of x comes out and multiplies. And then we have this thing, the derivative of sine is cos, derivative of cos is negative sine, derivative of tangent is 6 squared. Now, these basically are written for further maths, because this MF19 is basically for 9709, And the further maths, I think it's 9231, something like that. So it's for both of them. So basically, this is what we have. The rest, they will make us do the working. And tan inverse is there. This is 1 over 1 plus x squared. Again, keep in mind, it's with the coefficient of x. So the way that I have explained it over there, they have not explained it. They have not explained it like this. So you should be knowing this. So that is why this question was very special. And then we get this particular answer just by plugging in the limits and everything. Now this one, the equation of a curve is y is equals to e raised to power of negative 5x tan square x for x lying between pi by 2 and negative pi by 2. Find the x coordinate of the stationary points. Give your answer correct to 3dp. U is this, u prime is this. V is tangent x, the whole thing square, chain rule. Whenever we are dealing with exponential, common always comes out. This multiplies with this multiplies with this. So this blue thing is taken common out, plus tangent x can also be taken common out. We have this thing on the inside. We simplify it. We break it up. Middle term factorization. Now each term should equal to 0. E raised to power of something equals to 0. No solution, because we cannot take ln of this thing. This can also be explained graphically. Tangent x is equals to 0, we get these answers. Tangent x is equals to 2, we get this answer. Tangent x equals to half, we get this answer. And that's how the stationary points, or the x coordinates, are found. Another question of partial fraction. It's a proper fraction, but now look over here. There is a in the denominator. We follow the same process. We take LCM. The two fractions are identical. The numerator equals to the numerator. We work in terms of a. We make Q0 by taking x is equals to 3a. So we find the value of r. We take x is equals to half a, because 2x minus a equals to 0, 2x equals to a, x is equals to half a, in case anyone is wondering. We find the value of q, and that's how we get these fractions. And the next part, that is about integration. The limits are in terms of a. Hence show that this function that we just found the partial fractions of, if we integrate between these limits, the answer is ln 6. A beautiful question. So now focus over here. The coefficient of x is 2. This 2 is there. That's this 2. Half ln 2x minus 1. Over here, this is 3a minus x. Write this thing as minus x plus 3a. The coefficient of x is negative 1. 1 over negative 1 ln minus x plus 3a. Then simplify. Write it as a single fraction. My bad. So write it as a single fraction. Then plug in the limits. Simplify, and you get this answer. Another question related to long division. X cube, x square, x and constant. It's divided by 4x squared plus 1. You get a remainder of 6. Quotient remainder divisor. And they are asking us to find the exact value. Now, this thing over here is what? Take 4 common out. This is x squared plus 1/4. Write this 4 on the outside. This is x square half square. This is the constant, the concept, not the constant, the concept. So let me write it like this. So whenever we have this thing, which is 1 over, let me choose a thin marker. This is 1 over x squared plus a squared dx. This integral is 1 over a tangent inverse x over a plus c. Make sure it is a must that the coefficient of x squared should be 1. So that is the reason why this 4 was taken common out, so that the coefficient of x squared is 1. And that's how this working is done. That working was done a long time ago. And something like this, it's very similar to the one that we just practiced, or maybe it's exactly the same one. No, in that one, we found the area first and the limits were different. That was 0 to pi by 4. This is 0 to pi by 2. I'll just scroll it so you can have a good look at it. One last question of differentiation integration, because there is so much variety, I just cannot cut short on it. So, I mean, I feel that all these questions are good for the last minute. So now over here, the diagram shows the curve. This is of 2023, I think. The diagram shows the curve y is equals to this and its maximum point. Find the exact coordinates of m. U is x plus 5, u prime is 1, v is this much, v prime according to chain rule is this. dy by dx comes out to be this. Make it equal to 0, simplify, and you get the x coordinate. Y coordinate, you plug it in, and again you get answers in this weird exact form. The next thing, use the substitution u is 3 minus 2x. So now this is like algebraic substitution. We did a question that was strict substitution. Find by integration the area of the shaded region bounded by the curve in the x-axis. Give your answer in this form where a is a rational number. Now, first of all, in order to find the limits, what do? The y coordinate should be 0 because these are the x-intercept. X plus 5 equals to 0, x is negative 5, that's this. The square root equals to 0, therefore x is 3 over 2, that's this. So these are the limits. First of all, what is the step 1? The step 1 is u is 3 minus 2x, therefore du by dx is negative 2. I just want to substitute dx, so dx is negative half du. So this is negative half du. Just look at the color coding. 3 minus 2x square root. 3 minus 2x is u, so that is square root of u. And then what about x plus 5? You have to work it out. It's all about algebra. X is 3 minus u over 2. X plus 5 is 3 minus u over 2 plus 5. You simplify, and you get this. So that is substituted in this blue color. What about the limits? The limits are changed according to this equation, and the limits comes out to be 13 and 0. And what happens? I took this negative sign. I changed the position of these two. So 0 comes down, 13 goes up. And then it's as basic integration as P1, but after the substitution. Yes, and you have to play around with these fractions, with these powers, taking common. Just have a good look at it. What are the things that I've taken common? Then I get a 13 from here. I wrote 26 as 2 into 13. So this is 13 squared. This is 13 squared. I again took common. So now that's all about your basic maths. So that completes the part on differentiation and integration.
Recording in progress.
So now we are moving to the third part of this video that is related with differential equation and iteration. Iteration is the name of the process. Name of the topic is numerical solution of equations. Let's look at the first question. It's about a chemical process. There is a substance A, there is a substance B. Masses of A and B are x and y respectively. Dy by dt, the gradient function, the differential, that is negative 0.2 xy. X is 10 over this thing in terms of t. At the beginning, y is 100. That means t is 0. So now dy by dt is in terms of x and y, but x is expressed in terms of t. So therefore, we can only deal with two variables at one time, y on the left, t on the right. We will start the integration process simultaneously. This is 1 over 1 ln y. This is application of chain rule. Simplify. This is what you will get. E raised to power of this thing into e raised to power of c. E is a constant, c is a constant. Let e raised to power of c equals to a. We get this equation. When y is 100, t is 0, we get a as 100 over e. What are they asking us? They're asking us differential equation in y and t and solve this differential equation. So basically, we have made y the subject. The next one. The variable x and y satisfy this differential equation. Again, it's variable separable. So this is 1 over y dy. This is x plus 2 over x plus 1. Now, this is not a partial fraction case. Yes, it's an improper fraction, but that doesn't make it partial fraction. What we have to do is to simplify quotient, remainder, divisor. Now this one is integrated directly. 1 over x plus 1 ln comes into play. 1 over y ln comes into play. We integrate it. We take the two ln terms on one side. We have x plus c on the other. We simplify and we change. How do we change? We write it like this. Log y base a equals to x. Therefore, y is equals to a raised to power of x. So that is the logic. Log of this bracket base e is x plus c. So therefore, e raised to power of x plus c is this. Again, e raised to power of c is a, and we make it the subject.
Recording in progress.
Let's look at this question. Another differential equation question. Dy by dx is e raised to power of 3y sine square 2x. This is the condition that's given. Solve. Find the value of y when x is half. They're not asking us to make y the subject. dy over e raised to power of 3y, that is sine square 2x dx, take it up, e raised to power of negative 3y. Sine square 2x, we have to use the double angle formula, that is half bracket 1 minus cosine 4x. The formula is sine square x is half 1 minus cosine 2x. But since x is replaced with 2x, therefore 2x is replaced with 4x. So that is the logic. Then it's basic integration on both sides. There is a constant of integration over here. We plug in the condition, we find c is equals to negative 1/3, and there is no need of making y the subject. Now plug in x is equals to half, then work out and make y the subject, so we get this answer. Next question. It says for the curve shown in the diagram, the normal to the curve at the point P with coordinates xy. Normal to the curve at point P with coordinates xy meets the x-axis at N. The point M is the foot of the perpendicular from P to the x-axis. The curve is such that for all values of x in this interval, the area of triangle PMN, so PMN is equals to tangent x. Show that. So you might have solved some questions that are similar to this, but this is like nice one, a good question. So first of all, what I'm doing is that I'm writing tangent x is mn over pm. Tangent x. So therefore, tangent x over here, that is mn over pn. That is over here, pm, my bad. That is tangent. Now, the tangent is like this. If this angle is x or theta, if this is phi, theta plus phi equals to 180, equals to 90, then there is a 90 over here. So again, this phi plus this angle also adds up to 90. So those who study M1, they are very, very sure of this, that this theta and this theta is the same. Equation of curve y is equals to fx dy by dx or tangent x. That's the same thing. So mn over this thing. So mn is mn. We don't know what is mn. But what is pm? Pm is the y coordinate. So dy by dx is this much. Tangent x is replaced by this. Make mn the subject. So now it says that this is what they're asking for 1 mark, something basic, but not that basic. Hence, show that x and y satisfy this differential equation. Tangent x is half into base into height because it says area of triangle PMN. So now for this triangle MN and PM, MN and PM. So now we will substitute this MN from here, and then we work it out, and that is how we prove it. The next part is about solving this. That's nothing basic over here. Tangent is written as sine over cos. Numerator is derivative of denominator, almost, because the derivative of cosine is negative sine. So I wrote a negative over here. In order to balance it, I wrote a negative over here. That is negative ln of cosine x. This is basic integration. We plug in the value x is 0, y is 1. We find the value of c, and then we comfortably make it the subject. Another variety of differential equation. This one is 1 over y dy, 1 over x plus 1, 3x plus 1. That is partial fraction. We break it up into partial fraction. Don't expect the examiner that they will tell you every single step. You have to think it out. So this will give us ln, this will give us ln, this will give us ln. So everything will be ln. So therefore, this is 1 over 1 ln y, and this half is on the outside. And this 3 is also there. Actually, this is an application of that ln. I can either write this thing as 3 into 1/3 into ln 3x plus 1. That's one option. Or the numerator is derivative of denominator. The integral is ln of denominator. And then we find c. So c comes out to be negative half ln 2. That's the basic background. That's all shown over here. Now there are ln all along. Simplify and make ln y the subject. They're asking us find the exact value of y. So they are asking us give your answer in a simplified form. So therefore y is equals to ln. Actually, this half becomes over here. So y is equals to 5 over 4 raised to power of half. And I think the working is done over here. Similarly, another question of iteration, numerical solution in which graph has to be drawn, sec x. So the graph of sec is drawn between 0 and pi by 2. Pi by 2 is an asymptote. That's why it's not inclusive. And this is, it's going up like this. This is sec x. And this is a straight line, 2 minus half x. The y-intercept is 2. The gradient is negative half. It's going like that. We just have to show one point of intersection. Verify by calculation, root lies between 0.8 and 1. Make sure the calculator is in the radian mode. Make sure all the terms are on the left-hand side. Right-hand side is 0. Let's write this thing as fx, plug in 0.8, plug in 1.0. They are not interested in the value. They are just interested in the sign. Iteration, the best value to start with is the mid value. So 0.8 plus 1.0 divided by 2, that is 0.9. That is what I follow always. Show all the steps. I have skipped the steps. You shouldn't. Work in 4 decimal places. When the answer gets very, very close, that when we round it off to 2 significant figures, they're coming out to be exactly the same. That is when we stop. So this is 0.8680, which comes out to be 0.87. This is 0.8781. I think I should have to do one more step, which I skipped over here. Differential equation, something to do with proportionality. A curve is such that the gradient means dy by dx, is proportional to this thing. So how do you end the proportionality sign? Multiply by a constant of proportionality. There are 2 conditions over here because there are 2 unknowns. One is the constant of proportionality, one is the constant of integration. Rest of the working, you can just have a look. We are forming 2 equations. The second equation gave us k. We plugged it in over here. We find the value of c. Now, this one was a very nice question of iteration. So I'll just focus on the first part. That is the proving part. It says the diagram shows the trapezium ABCD in which AD and BC equal to R. AD and BC, this equals to R. That means this AM should be R and BM should also be R. And AB is 2R. So AB is 2R and M is the midpoint. So therefore, AM and MB. And if these 2 are not equal, how can we form the arc? The angles are given. Circular arcs of radius R with centers A and B meet at M. That is again re-emphasizing this point. AM and MB is the same. Given that the sum of the areas of the shaded region is 90% of the area of the trapezium, show that. Now for this trapezium, I need this DC. How can I find this DC? I can find from A to Q, which is the same thing from R to B. Subtract it from 2R, I'll find DC. So this plus this, half into that, into this height, that will be the area of trapezium. So this is the basic that I've shown over here. This is A, this is D. This is A, this is D in green color. This is A, this is Q, that's in blue color. So sine X is DQ over R, DQ is R sine X. And what is AQ? AQ is R cosine X. Area of sector, half R square X. Area of sector BMC, that is the total, that's the same thing as this. The total shaded area is R square X. Now, what am I left with? I am left with AQ plus QR plus RB. AQ plus QR plus RB equals to R plus R. And QR comes out to be 2R minus 2R cosine X. QR is 2R minus 2R cosine X. QR is the same thing as DC. QR is the same thing as DC. Area of trapezium, half sum of parallel sides into height. And this all working you have to do. Area of shaded is 90% area of trapezium. Area of shaded, that is these 2. Is 90% of this, simplify, and you get this answer. So it was a very trigonometry-based, circular measure-based question.
Recording in
So
progress.
let's move on to the next question. That is another differential equation question. Word problem type. It says a large plantation of area 20 kilometers square is becoming infected with a plant disease. At time t years, the area of infected is X. Rate of increase of X is proportional to the ratio of the area infected to the area not yet infected. That means if the infected area is X, not yet infected is the total minus X, which is 20 minus X. So ratio means X divided by 20 minus X. Proportionality sign, equal sign, we multiply by constant of integration, constant of proportionality. When t is 0, x is 1, dx by dt is 1. So now plug in dx by dt as 1. Now plug in x is equals to 1. Simplify, we find the value of k is 19, and this is the differential equation. Now it says solve the differential equation. Show that when t is equals to 1, the value of x satisfies the equation such and such. So first of all, what needs to be done is that dx goes with x and dt goes with just 1, or I can leave that 19 over there. So 20 minus x over x dx is 19 dt. Simplify, 20 over x minus 1 dx is 19 dt. This becomes ln. This is direct integration. This is direct integration plus a constant of integration. When t is 0, x is 1, c comes out to be negative 1. So now what do we have? We have 20 ln x minus x is equals to 19t minus 1. And over here, I'm taking x to the other side. Ln x is x plus 18 over 20, which is x over 20 is 0.05x. 18 over 20 is 0.9, x is this much. So that was a nice question. And then what have they done? They have used a differential equation with iteration. Very strange. So we work it out. We work in 4 decimal places. If 2 answers are very, very close, we stop. Calculate the value of t at which the entire population becomes infected. That means when x is 20, that's the entire population, plantation, not population, it's plantation. So, and we work it out and we get ln t, this value. So that would be ln 20 minus 0.9 divided by 0.05. That's the value of t. Numerical solution question related with circular measure. The diagram shows a semicircle with center O and radius R. Center O, radius R, radius R, radius R. Diameter is AB, that is 2R. The point P on its circumference is such that the area of the minus segment on AP, minus segment on AP is equal to half the area of the minus segment on BP. Show that X satisfies this equation. Now keep in mind, this is pi. So this would be pi, this is X, and this would be pi minus X. Sector OAP, that is this thing. That is half r square x. Sector OBP, that is half r square pi minus x. Triangle OAP, that's half AB sine C. Triangle OBP, that is using this angle. That is sine of 180 minus x is sine x. Area of segment, that is area of sector minus area of triangle. Area of segment, that is again area of sector minus area of triangle. The red area is equals to half the purple area. Red area is half the purple area. Half r square cancels out. Simplify and you get this.
Recording in progress.
So finally, we are almost till the end of the video. And this is the 4th part, that is vectors and complex numbers. So let's get started with this question. It says, relative to the origin O, the point A has position vectors such and such. The line L has this equation. Find the position vector of the foot of the perpendicular from A to this line. Hence, find the position vector of reflection of A in this line. Now, there are some very basic working in vectors. Sometimes they ask us for this perpendicular distance. Instead, they have asked us for the foot of the perpendicular. Very basic. So now, over here, OQ, that is the expanded form of the equation of the line. AQ, that is OQ minus OA. So this simplifies to this. Now AQ is perpendicular to this line. Therefore, the dot product of AQ and direction vector should be 0. We get mu as negative 5 over 2. Now, when I plug in mu is equals to negative 5 over 2, my bad for a second. So when I plug in mu as negative 5 over 2 in OQ, I'll find the point OQ. And the rest of the question is not done yet. Let me just explain what this is all about. So now this is, if they're asking for the reflection, that is the concept of like an image. That means AQ should equal to QS. In other words, Q is the midpoint of A and R, S actually. So therefore, what I'll do is that I'll write that A is 1, 2, and 4. And S is what I'm looking for, that is X, Y, and Z. Or I can simply write this thing. That is equals to, the Q is the midpoint. So A plus S divided by 2 or half equals to the coordinate of Q. And I'll find the coordinate of Q. That's right over here. This is, let me write in black pen, 8 plus 3 times negative 5 over 2. This is minus 3 minus 5 over 2. This is 4 plus 2 times negative 5 over 2. So this is OQ. That's the foot of the perpendicular. So therefore, I'll write half bracket 1 plus, I can even write just thing like this. 1, 2, 4. Let me write it like this. So this is 1, 2, 4. And instead of writing XYZ, I can write OS. This is equals to 8 minus 15 over 2. And this is minus 3 plus 5 over 2. And this is 4 minus 5. And just take care of the plus minus sign. I'll make OS the subject, and that is the answer. The next question, complex number. Now the questions are scattered randomly. Now the question says 5z over 1 plus 2i minus zz star plus 30i plus 30 plus 10i equals to 0. Giving your answer in the form x plus iy, where x and y are real. Let z is equals to x plus iy. Z star, change the sign of the imaginary number. So 5z over 1 plus 2i, what I've done is that I've worked with this thing. 1 over 1 plus 2i, I have rationalized this as 1/5 minus 2/5 i. So I've written 5 times 1/5, 1 minus 2i into x plus iy. I'm just working on this part. The green part is this part. And that simplifies to this. And I have taken this 30 and 10i to the other side. So what else is there? We also have zz star. So zz star is x square plus y square, but there is a minus sign. So there is zz star, that is x square plus y square. So let me write in the proper color. So let me choose a blue color for this. So this thing is this. This thing is this. And then this thing is the green one. So this green one over here, that is this thing. Now we will say the real part equals to the real part, the imaginary part equals to the imaginary part. We solve, and that is the answer that we get. Yes, we have to do a lot of working. Just have a good look at it. So let's move on. The next question is again about vectors. With respect to the origin, the points A, B, C, D have position vectors such and such. Find the obtuse angle between OA and OB. So that is an application of dot product, also known as scalar product, which is OA dot OB, that is OA modulus, OB modulus, cosine of theta. This is OA, this is OB. Multiply the I with the I, the J with the J, the K with the K, magnitude, magnitude, cosine theta. When cosine is coming out to be negative, naturally the answer will be obtuse. If they would have asked for the acute angle, I would just discard the negative sign and my answer will automatically come out to be acute. Now it further says the line L passes through the point A and B. Find a vector equation for line L, AB or BA. It's your choice. I found AB. I wrote it as the direction vector. Point A, point B, any one of them is ready to serve as the fixed point. So I've put one of them. Find the position vector of the point of intersection of line L and the line passing through C and D. So find another equation. I have CD. I can simplify it and just take this thing. Or I can use this as it is. The intermediate answers could be different. The value of parameters could be different. Lambda and mu are parameters, but the final answer will be the same. I have used OC. I have used CD. This is the expanded form. This is the expanded form for the other equation. And we solve it simultaneously. We multiply, we equate the x coordinate to the x coordinate, y coordinate to the y, and z to z. We'll keep it for the end. We solve, we find values of lambda and mu, plug in the last one. It says it intersects. They are not asking us to prove that it intersects or not. If they were, we would have plugged in the third equation, and lambda and mu will satisfy all three equations. So we will say it intersects. Otherwise, we will say these lines are skew lines if it doesn't satisfy all three equations. We plug in lambda where it belongs, we plug in mu where it belongs, and we get this answer. Another vector question. The quadrilateral ABCD is a trapezium in which AB and DC are parallel. Let me just check the recording thing. So, yes, it's all good. So now it says AB and DC are parallel with respect to origin O. The points ABC are given by such and such. Given that DC is 3AB, find the position vector of D. This is O-level math, except that it is in 3D. DC, OC minus OD, AB, OB minus OA. Make OD the subject. Very simple. State a vector equation for the line through A and B, just like what we have done. AB, we will take this as the direction vector. Any one of A or B can be taken as a fixed point. Find the distance between parallel sides and find the area of the trapezium. Now, I need to find the distance between parallel sides. That is this perpendicular distance. We have OA, OB, OC, OD. A point on the line AB, a point on the line AB. I'm calling it OP. And now find the perpendicular distance from C to this line. So I'm finding the perpendicular distance from C to this line. So now C is -6, -3, and 6. C is given as the original one that is over here. And what I'm doing, I am given OP as this thing. This is not C, this is CD. So therefore, CP is OP minus OC. That is OP minus OC. And what am I getting? I am getting the direction vector dot product with CP should equal to 0. Mu comes out to be 1. So if I want this perpendicular distance, I'll plug in mu over here. If I want to find C, I'll plug it in over here. Now, in order to find the area of the trapezium, I need sum of parallel sides. That is the magnitude of AB, the magnitude of CD. The CD is given. We can find the magnitude. I think AB was already given before, somewhere over here. This is AB, 2, 1, -2. So now what do we do? First find CP. This distance is 3. And I think the question was left incomplete. So I think it's half sum of parallel sides into height. So let me write over here half sum of parallel sides, that is AB, and the other one is CD into height, and the height is CP. Okay, what is magnitude of AB? So magnitude of AB, that's right over here, which is 4, 4, 1, which comes out to be square root of 9, which is 3. So this is square root of 9. What is magnitude of CD? That is 36, 36, that's 72, 72 plus 9 is 81, that's root 81. And what is the magnitude of CP? That is 3. So this is half, this is 3, this is 9, this is 3. 9 plus 3 is 12, 12 divided by 2 is 6, 6 into 3 is 18 units square. That is the area of the trapezium. Just double check my working since I'm doing it at a very high speed, so such errors might occur. So now another question. Find a vector equation. That's easy. Find the acute angle between the lines. Now look at this. The numerator is coming out to be negatives. If we take the negative sign into consideration, we get the obtuse angle. If we remove the negative sign, we get the acute angle. Show that the line through A and B does not intersect L. This is line AB, this is line L. Solve any two equation, plug in the remaining equation. It won't satisfy, therefore such lines are called skew lines. Another question of vectors, one with a box in it, a cuboid type of a thing. It says in the diagram, it's a cuboid, OA is 2 units. So this is 2 units along I, so this is 2I. Opposite direction would be -2I. OC is 3 units. Where is OC? This is 3 units. It's not drawn to scale, so this is 3J. AB is 3J. EF is 3J. DG is 3J. Opposite direction would be -3J. OD is 2 units. So this is 2 units. So this is 2k, this is 2k, and so on. MB is 2AM. MB is 2 times AM. That means the ratio of 1 AM is to MB is 1 is to 2. The ratio of AM is to AB is 1 is to 3. Keep that in mind. Express OM. Now OM, you start with O and you go till M. So this is 2I and this is 1J because this whole thing was 3J. So this is 1/3 of that. So this is 2I plus J. I have written in the IJK form. I have written in the column vector form. For working column vector is easier. Mn. So start with M, go all the way till N. So go this way, that is 2J. Go this way, that is 2K. Go this way, that is minus I, because I think it says the midpoint of FG is N. So that's right over here. Find a vector equation of the line through M and N. So -1, 2, 2. That's right over here. That is Mn. So use whatever you have calculated. And I can choose 2, 1, 0. That is as the M. So this is 2, 1, 0. Why? Because this is 2I, this is 1J, and it's on the ground level. So there is no K in it. And then it says, find the position vector of the foot of the perpendicular. We have seen a question just like that. R is the point on the line. That is OR in terms of lambda. That is the expanded form. DR, OR minus OD. Now, someone asked this question, can we find RD? Doesn't make a difference. Intermediate value of lambda will be different. Final answer will be the same. DR is perpendicular to Mn. DR dot product with Mn equals to 0. We get lambda. Sometimes we get a nice value of lambda. Sometimes we get a fraction like this. Expect the unexpected. So we found OR. And we found OP. They're asking for the foot of the perpendicular. So I think this is not P, this is still R. So let me just correct it. If they would have asked for this distance, we would plug it in dr and find the magnitude. That would be the distance. Complex number question again. Now it says verify that -1 plus root 2I is a root of this equation. So this is like the application of factor theorem. So what I've done is that from these two terms, I have taken common out and then I have plugged it in. Now just look at the working. It's not an easy working. You first simplify on the inside, you multiply algebraically, you take care of I square, and then you multiply over here, and everything should cancel out. You should get a 0. It's a quartic equation, power 4 equation. The complex roots are conjugates of one another. If this is a root, this is also a root. Apply the concept of P1, x minus p, x minus q, that is a quadratic factor. X minus this is a quadratic factor. And then work very, very wisely. Z minus minus 1 becomes z plus 1. Z minus minus 1 becomes z plus 1. This minus makes this positive negative. This minus makes this negative positive. This whole thing is like A. This is bi. This is A. This is bi. That's the shortest way. Z plus 1 whole square plus root 2 whole square. This is what you get. Now, let me just go back. And it's asking us what? They're asking us find the other roots. So what we have to do is to do the long division. And we get a quadratic quotient. And we break this up. And coincidentally, it's also coming out to be negative. So basically, we end up with 2 pairs of complex conjugate root. This is what we started with. This was by default. Based upon this, we got this. We got this. We did long division, we get the quadratic quotient. We checked with b square minus 4ac. We use the quadratic formula, and that is how we get the answer. Something to do with shading. It says on an Argand diagram, shade the region whose points represent the complex number z satisfying the inequalities. Argument lies between these two angles. Argument is a half line. First, do the adjustment. Z minus 1 plus 2i. So that is the launching point. So that is the point over here. 2 angles, draw it realistically. A lot of people, they ask this question, do we use a protractor? No, we use common sense. We just draw it realistically. And real part of z is x, imaginary part of z is y, x is less than or equal to 3. So we draw this line, we draw these two half lines, it's bounded between these two. Now it says calculate the least value of argument of z for points in this region from A. Give your answer in radians, correct to 3dp. So I have done it in two different ways. The first method is coordinate geometry and trigonometry. So I have this point, that is the purple line, that is this line over here. So this is 1, 2. This angle is given as pi by 3. So the gradient is negative root 3. I find the equation of a line. I solve it simultaneously with this equation, the green equation. That is x is equals to 3. And what do I get? I get this coordinate. X is 3, y is this. Just draw a triangle. This is 3. This is the y coordinate and find this angle. That's one approach. The other approach is I work with trigonometry only. Tangent of 60. So I'm just working like this or like this. So tangent of 60 is root 3. Tangent of 60 is CE over 2. So what is CE? That's from here till here. So I'm just working like this. So this value comes out to be 2 root 3. Y coordinate will be 2 minus 2 root 3 because this is 2. And this is the distance that we have gone down, 2 root 3. So therefore, this is 2 minus 2 root 3, which exactly matches with this. A very tricky question. And this value is given as 3. We find this angle. Another sketch. On a sketch of an Argand diagram, shade the region whose points represent complex number z. This is a circle. Make sure to do the adjustment. This is a half line. Make sure to do the adjustment. So it's inside the circle with a radius 1. Draw realistically. If this point is minus 1, 0, then a radius 1 means it should touch the y-axis. It should touch the x-axis. 1 unit this way, 1 unit this way. And this is 3 pi by 4. 3 pi by 4, that means this angle is 135 degrees. This angle is 45 degrees, which makes this triangle isosceles. So if this is 1, this is 1. Yes, that is how much what you call to the point precision thinking is required. And that's how a realistic diagram is drawn. So it is lesser than or equal to 3 pi by 4. So it's actually argument z minus 1 is lesser than or equal to 3 pi by 4. That means it could be between 0 and 3 pi by 4. And it's inside the circle. So it's above the line and inside the circle. So that is what we get. Another question. On a sketch of an Argand diagram, shade the region whose points represent complex number z. Z plus 2 minus 3i. The adjustment is needed. Argument of z is lesser than or equal to 3 pi by 4. And that is the diagram that we get. Again, a realistic diagram. Now let's look at this question. Find the complex number w which satisfy the equation w square plus 2i w star is equals to 1 and real part of w is less than or equal to 0. Let w equals to x plus iy, w star x minus iy, w square expand, iw star expand, and then plug everything in. So don't be in a hurry. So w star, w square is this one. 2 into I into W star. Actually, I into W star is up till here. And then multiplication by 2, that's 2y plus 2xi. And this equals to 1. 1 can be written as 1 plus 0i. Real, 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 equated. Imaginary, 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 equated. So we get values of x is 0, y is minus 1. And it says real part of w is less than or equal to 0. So x is less than or equal to 0. And x is negative 2. When x is 0, y is 1. When y is negative 1, x is minus 2 or plus 2. So we will end up with this answer that is 0 and 1. That's this answer. And this is minus 2 and minus 1. We are rejecting this answer. Similarly, a question of the same sort. V plus iw is equals to 5. 1 plus 2i into v minus w is equals to 3i. Make v the subject. Plug it in over here. Expand. What do we get? We are getting not a quadratic equation, but w minus iw is this thing. Make w the subject. We get something like this. We have to rationalize and we get w as this. Now plug it in over here. We find the value of v. So it's like a lot of hard work that needs to be done because it's P3 and it's much more higher than P1. Just the part B, loci on an Argand diagram, sketch the locus of points representing the complex number Z. Now, this is just sketching, just drawing, not a shading question. And then it says, calculate the least value of argument of Z. Now, originally, I drew this diagram a bit smaller, but the main parts, I have made it in an enlarged version. They're asking the least value of argument of Z, that is this angle right over here. Now, how I have worked it out, the radius is 1, this is 2, 3. So this Pythagoras theorem is giving me root 30. So therefore, sine of theta is 1 over root 13, that is 16.1 degrees. And where did I find this angle? This is 2 and 3. So that's 2 and 3 is right over here. So this is like 2 and 3, that's right over here. So what I've done is that I found beta and the difference between 56.3 and 16.1, that is the answer. So therefore, this thing is the answer between these two. Actually, that is this one. This whole thing is 56 degrees. This thing is 16 degrees. So the difference is this one. So that is how we end up with this particular thing. And another question, the complex number u and v are defined by such and such. Find u over v in this format. So rationalization. Hence express u over v in the form rei theta. So this is -1, this is +1. Basic angle is 45 degrees. This angle in the second quadrant is 3 pi by 4. Magnitude, that is basic Pythagoras theorem. We write it in the trigonometric form, also known as the polar form, also known as the modulus argument form. Just take this, that is r. Just take this, that is 3 pi by 4. Very simple. In an Argand diagram where O is the origin, the points A, B, C represent the complex number. So now this is like vectors and geometry and just a graph thing. State fully the geometrical relationship between OA and BC. OA, that's -4, 2. OB, that's 3, 1. OC, that is given. OC is this thing, that is 2u plus v. 2u plus v. BC, that's OC minus OB. So if I take 2 common out, this is -4, 2, -4, 2 is OA. So what's the relationship? That is BC is equals to 2 times OA. If one vector is a scalar multiple of the other, that means we can say they are parallel vectors. Prove that angle AOB is 3 pi by 4. One method is to use scalar product. OA, OB, scalar product, we get this answer. Some people can also use cosine rule, find the magnitude, find the magnitude, find the magnitude. And
Recording in progress.
Let's get started with this. With respect to origin O, the points A and B have position vectors such and such. The line L has this equation. Find the acute angle between AB and L. AB, this is the direction vector. And this is the direction vector for line L. That is an application of scalar product. The numerator is coming out to be negative. Remove the negative sign, we get the acute angle. Find the position vector of the point P on L such that magnitude of AP and BP is the same. They have simply written AP and BP. What they mean is that the magnitude. OP is this, AP, OP minus OA. BP, OP minus OB. In terms of lambda, x square, y square, z square under root, x square, y square, z square under root. Quadratic equation, you find the value of lambda, you find OP. Complex number, square root, very important. U is 10 minus 4 root 6i. Square root of this complex number is a plus bi. Square both sides. That is a square plus b square, a square plus 2abi plus b square i square. We know that I square is -1. So therefore, this goes with this. A square minus b square, that's the real part, equated to 10. 2ab equals to -4 root 6. I made b the subject. I plugged in over here. I get a disguised quadratic equation. I solve, and this is all pure math 1. So that's how we get the answers. Now, these square roots, they have nothing to do with the roots. They have nothing to do with the conjugates. Another question of differential equation. I think we have done differential equations before, so let's skip it. So now this is with respect to origin O. OA is this, OB is this. Show that OA is equals to OB. Use a scalar product to find angle AOB. Take two vectors diverging from a point when they ask for an angle with the name. Either both vectors should be diverging or both should be converging. One other thing, OM is half OA plus OB. Remember this rule. This is just like the midpoint formula. A lot of people, they have a misconception that OM is half of AB. That's totally wrong. AM is half of AB, or MB is half of AB. Now it says the midpoint of AB is M. The point on the line through O and M is such that the magnitudes are in this ratio √7:1. OM is found, and we are not sure where P is. So let me find the equation of the line passing through origin, and M, it's on this line. So OM is used as the direction vector. The best point to use for the fixed point is the origin. So OP is this. What is PA? OA minus OP. That's the magnitude of PA. And similarly, PA is to OA is √7:1. PA is √7 OA. So magnitude of PA is √35, because this OA, the magnitude is given. I think OA is given somewhere over here. There it is. So OA, this magnitude is √5. So √7 into √5 is √35. Now the square root disappears. Solve, we get two values, and both values are acceptable. Another complex number question, nothing special. I just plugged it in over here. It's the same simultaneous type story. Vectors, a question with a diagram, and it says find a vector equation for line through M and N. So first of all, this is, I think, 4 units, and this is also 4 units, and I think M is the midpoint. There it says. So this is 4i, this is 2j. So 4i, 2j, 0k, that is 420. And what about N? How do we find N? So N is over here. They are saying Dn is 3nc. So Dn is 3/4 of nc. Now, before that, I need to find what is dc. OD plus dc is OC. OD plus dc is equals to OC. So therefore, I made dc the subject. And dn is 3/4 of that. So dn is 3nc. dn is 3 times nc. In other words, dn is 3/4 of this. So that is what I've used over here. And then I found on, and then on is 031. And what are they asking? The line through M and N. So this is OM, this is ON, this is the vector between M and N. Doesn't make a difference whether it's MN or NM, it's MN. And 031 I have used as the fixed point. So it was kind of elaborate working that needs to be done. Length of the perpendicular, that's the same old story. A complex number is given such and such, minus √3 plus I, x coordinate negative, y coordinate positive. Therefore, this is where? This is in the second quadrant. Basic angle is pi/6, because if this is like this is 1, this is √3, this basic angle is pi/6. But since it's in the second quadrant, this is 5 pi/6, pi minus pi/6. Trigonometric form, exponential form. Good question. Show that u power 6 is real and state its value. Magnitude of u is 2. Magnitude of u power 6 is magnitude of u raised to power of 6, which is 2 raised to power of 6, which is 64. Argument of u is this much. Argument of u power 6 is 6 times this, which is 5 pi. What does 5 pi means? That means this is 2 pi. This is 2 pi. That's 4 pi. Plus pi. This is 5 pi. Technically, it's the same thing as pi. Sine of 180 is 0. Cosine of 180 is -1. This comes out to be -64. It's real because there are no imaginary part. And what is the value? That is -64. On a sketch of an Argand diagram, shade the region whose points represent the complex number z satisfying the inequality. Z minus u lies between pi/4 and 0. So now this is related to the previous part. I think u is this. -√3 plus I. So z minus -√3 plus I. That is the point. And one half line is making an angle of 0 degree. The other half line is making an angle of 45 degrees. Real part of z is less than or equal to 2. X is less than or equal to 2. Find the greatest value of modulus of z. Modulus means greatest means maximum. Modulus means distance from origin for points in the shaded region. It's not a shaded region. It is just this particular region. So I'm looking for this point. So now this is basic geometry, trigonometry. AB is equals to BC. AB is equals to BC. Why? Because it's a 45-degree angle. So this is negative root 3. This is 2. So this is 2 plus root 3. So this is 2 plus root 3. That is this. And OD, from O till D, this is 2 units. So this is 1 unit. This is 2 plus root 3. This is 2 plus root 3. 1 plus 2 is 3 plus root 3. And this much is 2. So that is how we do the working. And that's how we get this answer. And one last question that is from the yesteryears. That is not this part, not needed. Sketch an Eigen diagram showing the region. And this is z minus 4 minus 4i. When we do the setup, this is a circle, center 4, 4, radius 2. Now, for the complex number represented by the points in the region, it is given that magnitude of z lies between p and q. Argument of z lies between alpha and beta. That means this is the least value, greatest value, least value, greatest value. Find p, q, alpha, beta, giving your answer correct to 3 SF. That's the circle. That is the center. That is the radius. For argument, this is the least. For the greatest, this is the answer. We are using the property tangents drawn from an external point to a circle are equal in length. So if this is 4 and this is 4, this is root 32. This is 2. Therefore, I can find theta. Sine of theta is 2 over root 32. This is also theta. That means this angle is 45. Why? Because this is 4, this is 4. Isosceles. Therefore, what is the least value? That is 45 minus theta. And the greatest value will be 45 plus theta. Least value 45 minus theta, greatest 45 plus theta. How do you find theta? There it is. Theta is 2 divided by root 32 sine. And what else is left? This thing, magnitude of z. That means the distance from origin to the circle. This distance is root 32, radius is 2. So therefore, if this is point A, this is B, this is C, this is D, AC is root 32. If I subtract the radius, I get the least value. If I take AC and add the radius, I get the greatest value, and that's all about it. So another diagram for this, and the last key messages for you to get a nice grade. Read the question carefully. No compromise on that. Draw a sketch or diagram can often help candidates to understand and apply the info given. For an answer to be fully correct, it needs to be supported by clear working as stated in the rubric on the question paper. That is the instructions on the first page. And key messages. Read the question carefully. Make sure your answer matches the demand. If it's asking for the exact value, therefore fractions and surds and pi and e and ln, it should be given. And then it says, take care with the basic algebra and arithmetic. So that's the basic algebra and arithmetic, because many marks were not awarded due to basic slips. If a question asks for an exact answer, then a decimal approximation is not an acceptable substitute. In a show that question, take extra care with giving a full and clear explanation. Do not overwrite one solution with other, as it makes it difficult to read when scanned. Your work needs to be legible. In particular, the numerals need to be clear and not ambiguous. So that is all from my side in this elaborate thing. Take your time, jot down the main points that I've explained in this particular video. And that is just my educated guess for you people to get the best possible grade. And take care, everyone. And good luck in the exam.